In the quest to develop new technologies in unmanned systems and enable the cooperation between air, ground, and water-based robotics, collaboration-based Robotics and Automations Group was created in the Department of Electrical and Computer Engineering at the University of New Brunswick. We are known as COBRA. To advance the state-of-the-art, COBRA has embarked on the design, construction, and implementation of several unmanned vehicles for the purpose of creating a framework that will allow these very different vehicles to cooperate in accomplishing a common goal. This project is both expansive and multidisciplinary, but COBRA has the right researchers to get the job done. Our supervisor and pace setter is Dr. Howard Lee. Our mechanical engineering systems expert and head pilot is Carl Thibault. Simultaneous localization and mapping is headed by Syed Saidi. Underwater robotics and path planning is under Liam Paul, and Tyler Edwards is implementing GPS and working on the ground vehicles. COBRA's first unmanned aircraft was an electric-powered helicopter from the radio control community. 2 units were successfully built, flown, and interfaced with microcontrollers. Seen here, Hummingbird 1 is being tested for stability and response of the commercial platform. The smaller of the 2 helicopters was fitted with an onboard microcontroller. This interface allows our system to send control signals to the rotor head actuators and main motor, allowing the computer to control the aircraft. The test displayed here was to assess the effective latency added by the microcontroller as it interpreted the pilot inputs and recreated the appropriate control signals. Having proven that interfacing with a commercial system was viable, COBRA turned its attention to software. To develop and test control algorithms without the need of actually flying the robot, the Charles River Flight Simulator was modified to provide a virtual environment. Testing the system in software greatly reduces the development time and allows precise comparison of controller performance. The pilot will control the unmanned aircraft using a graphical user interface such as the one shown here from Expo. The operator can enter and upload sets of waypoints that the aircraft will attain in the specified order. Each vehicle will carry a payload of sensors and computer hardware. The heart of the onboard system is an embedded Linux computer the size of only a stick of gum. Software running on this single-board computer controls all the functions in the aircraft and collects information about itself and the surrounding world. To cover a lot of ground quickly, an airplane is the way to go. An electric foam glider was fitted with the necessary sensors to measure its orientation and conduct autonomous flight. The desire is to collect aerial imagery for forest fire protection with this class of vehicle. To operate in indoor and confined areas, COBRA has developed a quadrotor vehicle. This type of helicopter uses its 4 independent motors to fly. Varying the power to individual motors controls its orientation, while increasing the power to all the motors will make it rise into the air. This may sound very simple, however hundreds of corrections per second are required to accomplish a controlled flight. Since no commercial solution is available, COBRA has designed a custom platform for carrying 2 scanning laser rangefinders. These sensors allow the quadrotor to collect enough data to recreate its environment in 3 dimensions as it moves through it. This will be required for navigation when GPS is unavailable, or to create a detailed map to allow a ground vehicle to trail a flying robot. COBRA has come a long way since its conception in 2009, and the future is bright for this team of skilled and dedicated researchers. Look for more updates for this team in the near future.